So, what is hydropower plant? Hydropower plant is electricity generated by turbines that transform the potential energy of falling or fast-flowing water into mechanical energy. Hydropower plant was the most extensively used renewable energy source in the early 21st century. Low-cost hydropower was viewed as one of the greatest solutions to fulfill rising energy demand, and its growth was frequently linked to the expansion of energy-intensive businesses such as aluminium smelters and steelworks. Hydropower was initially used to generate electricity in the late year 1800s, a few decades after British-American engineer James Francis invented the first practical water turbine. Along the Fox River near Appleton, Wisconsin, the world's first hydropower plant commenced operation in 1882. Hydropower development regained traction shortly after the turn of the century, notably in Asia and South America. Between 2000 and 2007, 500 gigawatt of installed hydropower capacity was added globally. For hydropower plant development, the early 20th century saw fast breakthrough and modification in hydropower plant design, during which time North American expansion dominated hydropower development. President Franklin D. Roosevelt's policies, particularly the New Deal in the 1930s, aided in the building of major multi-purpose projects like as the Hoover and Grand Coulee dams, with hydropower accounting for 40% of the country's electrical supply by 1940. In addition, Brazil and China became world leaders in hydropower in the late 20th century. On the other hand, the Bakun hydroelectric project, located in the Malaysian state of Sarawak, is the biggest in the country. With a capacity of 2,400 megawatt, it is now the world's third tallest concrete face rockfill dam, with a 750 meter long crest, a height of 205 meter, and fill volume of 16.75 million meter cube. There's a few types of hydropower plant. Firstly, impoundment. A dam is used in an impoundment facility, which is often a big hydroelectric system to hold river water in a reservoir. The reservoir's discharge water runs through a turbine, turning it and activating a generator, which produces power. The water may be released to satisfy changing electrical needs or other requirements like as flood control, recreation, fish passage, and other environmental and water quality requirements. Next, diversion. Often known as a run-off river facility, directs a section of a river via a canal, a penstock, to generate electricity by utilizing the natural drop in riverbed height. A penstock is a closed tube that directs the flow of water to turbines via gates, valves, and turbines. A dam may not be required for a diversion. Another kind of hydropower, known as pumped storage hydropower, or PSH, functions similarly to a large battery. A PSH plant may store electricity generated by various sources of energy, such as solar, wind, and nuclear for later consumption. These installations store energy by pumping water from a lower elevation reservoir to higher elevation reservoir. The objective is to introduce a hydropower plant that uses optimal energy in the water while minimizing submergence and economic expenses, while accounting for seasonal fluctuation in power output to fulfill the region's demand throughout the year. In addition, the objective is to explain the function and construction process of hydropower plant to the community of destination, as it inexpensive in the long term of using it.
The image shows the primary components of a hydropower plant. The type is impoundment. First, dam. A dam is an artificial concrete barrier constructed across the river. The catchment area behind the dam creates a huge water reservoir. Second, pressure tunnel. Water is transported from the dam to the valve house via the pressure tunnel. Surge tank. Another safety component connected to hydroelectric power plants is the surge tank. The tank height must be higher than the water's head as it is kept in the reservoir behind the dam. This is an open-top water tank. Fourth, valve house. There are two different types of valves available in the valve house. The first one is the main sluicing valve, and the second one is an automatic isolating valve. The penstock is a steel pipeline of appropriate diameter connected between the valve house and power house. The water flows down from the upper valve house to the lower power house through this penstock only. Last, power house. In the power house, there are water turbines and alternators with associated step-up transformers and switchgear systems to generate and then facilitate transmission of electricity.
I'm going to explain about the technology that had been used in the hydropower plant. The first technology that had been used is the fish-friendly turbines. the fish-friendly turbines is used to protect the fish and increase the fish passage survival. To reduce risk on fish, Eldon turbine has been utilized where it only has 3 blades wrapped around the shaft and it is equipped with a feature of relatively thick circular entrance edges to minimize the damage of fish. The Eldon turbines is also an innovation from Pence's turbine. Second is the Pump Storage Hydropower PHS. Pump Storage Hydropower PHS can be defined as a configuration of 2 water reservoirs at different elevation to generate power as water moves down from one to another, passing through a turbine. In other words, PHS acts like a battery as it can store the water and release it when needed. So, how does PHS works? First, water will flow from the upper reservoir into the turbines. The turbines will then generate the generators, causing the water to flow into lower reservoir. Then, the turbines will spin the generators backward to pump water into the upper reservoir. This cycle will then remain the same. Digitalization of hydropower plant had allowed the transfer functions of dynamic behavior of the reservoir, penstock, surge tank, turbines, and generator. So the advanced grid supporting system to provide reliability and safety to the station. The use of digitalization can prevent failures, reduce outage time, addressing cybersecurity risks, rehabilitation, increase overall efficiency, and produce energy. One of the examples of digitalization is the Hydro Efficiency Analysis (HYDEA) platform, where an algorithm analyzes the behavior of the plant to detect the deviations from the expected values so engineers can deal with problems that reduce the plant's efficiency. Here's are the figure of the HYDEA platform. Lastly is the Archimedean screw. Archimedean screw can be described as a screw inside a tube and it is widely regarded as friendly to wildlife as fish can pass through them more safely. It also commonly used for low heat or high flow sites. When used as hydro turbine, the water at the top of the screw moves down, rotating the screw as it travels, which causing the rotation to generate electricity. Relatively, the work principle for Archimedean screws is the same as any hydro turbines, but it acts in reverse.
Hydropower plant is non-polluting, but it does have environmental impacts. Hydropower facilities can affect land use, homes and natural habitats in the dam area. Reservoir may cover people's home, important natural areas, agricultural land, and archaeological sites. The next issue is the initial price. Although hydropower is seen as a cheap source of energy, it has a significant drawback. The construction of industrial-scale hydropower plant is quite expensive and take a lot of resource, time and manpower. Even today, building a hydropower plant is an extremely complex operation that may call for the skills of highly qualified engineers and architects who may be difficult to come by in developing nation. Hydropower plants have the potential to alter or destroy fish habitat, trap fish and restrict their migration routes. Dam control flooding in addition to generating energy. However, many creatures rely on the regular annual flooding of the area next to a river or lake as a natural process. A river slowing down will worsen its water quality, drive out some species, and improve conditions for others. Nevertheless, during the mating season, some fish species like salmon will swim upstream and a dam may block their way. In order to contain water during flood or conversely, to produce energy during shortage, dams are built with certain precipitation in mind. However, as more frequent extreme weather catastrophes like hurricane, droughts, and others, new dams must consider these realities and the suitability of existing dams must be assessed.
The conclusion that has been made is we should promote the usage of hydropower since it does not pollute the environment or emit greenhouse gases. Hydropower plant is one of the cleanest, most dependable and least expensive energy sources. There are several reasons why more hydropower plant, such as the fact renewable form of energy that does not contribute to global warming or climate change as fossil fuels such as oil do. Furthermore, hydropower plants guarantee stable electricity delivered by permitting consistent electricity generation, which is not the case with other renewable energy sources such as solar and wind energy. Last but not least, hydropower plants have a long history of usage and create the world's greatest percentage of renewable energy, far exceeding that of solar, wind, and geothermal energy. Project designers should clearly identify any specific environmental and social criteria that apply to hydro projects of different sizes and types. For designer and project developers to effectively and consistently compare alternative hydropower project and project array, appropriate environmental and social decision-making criteria must be used. These criteria will be set by government agencies or regulators responsible for approving and licensing hydropower development. The second one is renewal and upgrading of existing power plant, and adding hydropower facilities to existing dams should be promoted. Project designers should develop and apply tools to assess the merits of project alternative from an environmental and social perspective, and consider both negative and positive impact in the prioritization of the alternative. Lastly, the project designer should apply environmental and social criteria to various project alternatives early in the planning process to ensure selection of the most appropriate alternative for development. Existing hydropower facilities that are aging, have poor reliability, and have the potential to provide more power or system flexibility in an economic manner should be considered or upgraded.